Welcome to Flawless Mathematics. Let's start our new series of this channel. That is, I will start to cover each and every chapter of NCERT books. So let's start our new chapter, that is matrices. So in your book there's chapter 3 named matrices. So first of all, what is matrix? So matrix, what is matrix or definition of matrix? So matrix is basically a rectangular array. You know the array. So array of numbers, it can be array of numbers or it can be array of functions, right? So this is the definition of matrices, that a rectangular array or ordered rectangular array, you can say, of number and functions are called, the numbers or the functions are called the elements of array, right? Elements of array. And the process in which the ordered numbers or ordered functions, or you can say entries of the matrix, so it denote it by capital letters basically. Okay, so let us take a real life example. So what is about real life? Suppose we wish to express the the book name or book name, and suppose another one is the book number, right? Book number. So there's a book name, suppose A, B and C, and book number according to the book name is suppose 21 or 21, 22 and 23. Now if we express this book name and book number in a rectangular array, that is A, B, C and 21, 22, 23 in this way, so this is basically a nothing but a matrix, right? So in your book there's a very good example about Radha, Fauzia and Simran. So it's about notebooks and pen. So see, here's the example. So this is the matrix is 15, 10 and 13. This is the column, first column, and second column is 6, 2 and 5. And here this is the first column and this is the second column, and these are the row, that is, this is first row, this is second row and this is third row. So how can we write it? So this is basically the first arrangement. The entries in the first column represent the number of notebooks processed by Radha and Fauzia and Simran, right? And Simran. And the second column represent, is the number of pen. For this is number of pens, 6, 2 and 5, and this is the number of notebooks. Okay, so this is also a example of matrices. Now let's move to the next topic. So okay, here's also in your book definition 1. So then order of matrix, right? So now finally we will go for the next, that is order of matrix. So what is order of a matrix? Suppose there are in a matrix A there are 3 columns and 3 row. Okay, 3 columns and 3 row. So this is 3 cross 3 matrix. Okay, that is, this is 3, rows number is also 3 and columns number is also 3. So this is basically a 3 cross 3 matrix. So what is the definition of order of matrix? A matrix having m rows and n columns is called a matrix of order m cross n. Okay, m rows and n columns is called a m cross n matrix. So this is basically a order of matrix. Now what is the types of matrix? Okay, there is also an example from your book. See example 1. Okay, example 1. So what it says? It says, consider the following information regarding the number of men and women workers of 3 factories 1, 2 and 3. So there are men workers and there are women workers. So first factory is men workers is 30 and women workers are 25, and for second factory 25 are men workers and 31 women workers, and number factory 3, for factory 3 27 are men workers and 26 are women workers. Now represent the above information in the form of 3x2 matrix, obviously. So what is the matrix here? Here matrix is 30 25, 25 31 and then 27 26. So this is men workers and this is women workers, right? So and what is the question here? What does the entry in the third row and second column represent, right? So represent the above information in the form of 3x2 matrix. So this is a 3x2 matrix, okay, because here are here 3 rows and 2 columns. So this is 3x2 matrix, and the entry in the third row and the second column represent the number of workers in factory 3. So the number of women workers in factory 3. How you may know it? So you may know it because there's see, from the matrices we know that this is the entry of from the factory 3, right? And this is the men worker and this is the woman worker. So this is factory 3 and this is woman worker. So the third row, that is first row, second row, third row, and second column, this is first column and second column. So the entry is 26 to 26 represent the number of women workers in factory 3. Okay, get it? Here's also some example 2 and example 3. Okay, you will do it by yourself. Now types of matrices. Okay, so types of matrices. Next topic is types of matrices. So first type is column matrix. So this is the first type of matrix. So a matrix is said to be a column matrix if it has only one column, that is there are no row in the matrix. This is called as column matrix. For example, if we take A matrix, that is 2 3 5, this is a example of column matrix. So there is one column, so this is column matrix. And as usual for the row matrix, if there are one row, that is if it has only one row in the matrix, so this is a row matrix. B matrix 1 2 3 4. Okay, now third type of matrix is square matrix. So square matrix is nothing but if the order of a matrix is m cross m, that is the number of row and the number of column is same, then it is called square matrix. If example 2 3 4 5. Next is diagonal matrix. So what is diagonal matrix? This is diagonal matrix. If a square matrix is said to be diagonal matrix if all its non-diagonal elements are 0. For example, if this is 2 0 0 and 5, so this is a diagonal matrix, that is non-diagonal elements are 0. Now number 5 is scalar matrix. Now scalar matrix. So what is scalar matrix? A diagonal matrix is said to be scalar matrix if its diagonal elements are equal. That is, suppose there's an example of okay, let me clear it. So what is the example of scalar matrix? So suppose A is 2. This is also a scalar matrix. Or suppose another example, let us take, this is 2 0 0 and 2. This is also a scalar matrix, right? So basically scalar matrix is a diagonal matrix is a form of diagonal matrix, and a diagonal matrix is said to be scalar matrix if its diagonal elements are equal. See, here all the diagonal elements are 2. this is a diagonal elements, the diagonal matrix. So this, here's a difference between, here see, here diagonal elements are 2 and 5, so this is not equal, okay, but in scalar matrix the diagonal elements are equal. Suppose, let us take another example of scalar matrix. So 0 and root 2, 0, 0, then 0 root 2, 0, and 0 0 root 5. So this is a diagonal matrix, but instead of root 5, if there is root 2, that is all diagonal elements are equal, so this is a scalar matrix, okay. So here's a small difference between diagonal elements, a diagonal matrix, and scalar matrix. Now let us move to the next type of matrix, that is identity matrix, okay, identity matrix. Identity matrix. So identity matrix, let's incorporate and another matrices, Aij equals to 1 if I equals to j, and 0 if I not equals to j. And what is I and j here? So this is basically order, that is or you can say the number. Okay, let's take an example. Matrix capital A equals to 1 0 0 0 1 0 0 0 1. This is an identity matrix. Why? Because see, this is A 1 1, this is A 2 2, that is first row and first column of capital A matrix, right? So this is 1, and it is represented at small a 1 1. Similarly, second row and second column of A matrix, that is small a 2 2, and first third row and third column of capital A matrix, that is A 3 3. So if A 1 1 for 3 cross 3 matrix, A 1 1, A 2 2, and A 3 3 equals to 1, and all other elements are 0, so this is basically a identity matrix. And next is identity matrix and then zero matrix. So what is zero matrix? So zero matrix is nothing but if all elements are 0. If all elements in any order of matrix, that is 2 cross 2 or 3 cross 3, if all elements are 0, then it is called as zero matrix. And the last one is equality of matrix. Equality of matrix. So what is equality of matrix? So equality is matrix is if a matrix A and B is said to be equal if they are, first of all, their condition, first condition is if they are same order. So what is order of matrix? You already knew it. So 2 cross 3, if A is a 2 cross 3 matrix and B is also a 2 cross 3 matrix, so this condition is hold equality of matrix. And what is the second condition? That is the second condition, this is the first condition, and the second condition, each element of A is equal to the corresponding element of B, that is Aij equals to Bij. Let us take an example, right? So suppose the matrix A is 3 5 2 1. So equality matrix is if B equals to 3 5 2 1. Why? Because this is also they are A and B are the same order of matrix. And number 2 is, see here A 1 1 is also 3, and here B 1 1 is also 3, and similarly A 2 2 is also 1, B 2 2 is also 1. So this is equality of matrix. Okay, so then in your book there are example 4. Okay, so find the values of A, B, C, X, Y and Z. So this is okay, let us do this example in your book named example 4. Example 4. So let us take X plus 3, Z plus 4, the matrices, and 2y minus 7, then minus 6, A minus 1 0, and B minus 3, minus 21 and 0. This is matrices. And then another matrix is 0, 6, 3y minus 2, minus 6, minus 3, 2c plus 2, 2b plus 4, minus 21 and 0. This is another matrix. So here it is given that their corresponding this is okay. These two matrix, if let us name it A and let us name this matrix B. So this is equality of matrix. So what is the condition of equality matrix? That is, there are same order. See, both are 3 cross 3 matrix and corresponding elements are the same. So x plus 3 equals to 0. So x plus 3 equals to 0. So the value of x equals to minus 3, and then a minus 1 equals to minus 3. So a minus 1 equals to minus 3. A equals to minus 3 plus 1, that is minus 2, right? So in this way you can find A, B, C, X, Y, Z. Okay, so let's end today's discussion. We will forward exercise. Okay, exercise 3.1. okay, homework. Do it by yourself. That is exercise from exercise 3.1. You can do 1. We'll do 1. You will do 2, 3, and okay, up to 7 you can do it by yourself. And from okay, this is very easy questions are there. You can take it your homework exercise 3.1. okay, if any problem in exercise 1, you can comment with the question number, okay, ta-ta.